In this video, we're going to be talking about symmetry. We're going to start by talking about line symmetry, and in the second half of the video, we're going to talk about rotational symmetry. So it says here, the definition of line symmetry, another name for reflection symmetry. So I hope you know if something's symmetrical, it's the same on both sides. So it's when one half is the reflection of the other. So this doggy is well, it looks like they've just taken the picture and split it in half, but it's exactly the same on both sides of this line of symmetry. The line of symmetry shown here in white is the imaginary line where you fold the image and have both halves match exactly. So I have two examples down here of pretty much the same picture, but notice they put the line of symmetry in different places. So here it says, is the dotted line a line of symmetry? So this one, which is cutting sort of, I guess say horizontally through the leaf, you'll notice if I folded that over, it would look exactly the same. So yes, this line here does create a line of symmetry, through the middle. However, in this other leaf example, they've tried to put the line this way vertically through the leaf. But if I fold it in half, this side has the stem and this doesn't, it wouldn't match up. This is not a mirror image of that. So on this one, no, it is not a line of symmetry. I'm just going to show you two more examples illustrating this concept because I think it's pretty straightforward. In this one, it says, is the dotted line a line of symmetry? So this is a little tricky, kind of like the other leaf one, because the image itself is very symmetrical, but where they've placed that line, it's not the middle. If the line was in the middle, then yes, you could fold it in half and it would definitely be symmetrical on both sides. But because they've stuck this line over here, if I folded that where the line is, this part is way shorter than this part. The middle is over here. So because of the placement of that, no, that is not a line of symmetry. This one, it's interesting because yes, they put it in the middle, and yes, the bucket is symmetrical, but because they have this little cute frog on this side, it is not a mirror image of this side. There's no cute frog. So, no, that's not symmetrical either. In this part of the video, we're going to talk about rotational symmetry. So rotational symmetry, if a shape has that, a shape has rotational symmetry when it still looks the same after some rotation. So if you take it and you're able to turn it around. So with these two shapes, we can see that, so that's obviously symmetrical. I know it might be a little bit, it should be the same size, but that's hard for me to maintain on here. But I can take this shape and I can spin it all the way around, whoops, and then it looks the same again. See now the two, you can kind of see the two is in a different spot, but the shape is symmetrical. Should be exactly the same size, but that's a little bit hard for me to do. And again, obviously I can spin that around. Same with this shape over here, number 3. I can take this other one and I can turn it. Looks the same. Turn it again. Looks the same. And over on the side, we see other examples of rotational symmetry. They're talking a little bit about the order in terms of how much you have to turn it around in order for it to be symmetrical. Again, we're not that worried about that, but I just want you to see these visuals. So this is some little kid's art. You can imagine that if you turn this, I guess we'd say 180 degrees. So all the way around, it would match again. This we're turning partway around the circle. I think that'd be 60 degrees. And this, as every time you change it, every 90 degrees, it would be the same. And right here, same thing, where turning looks the same. So here's an example from the practice activity. Which picture has rotational symmetry? So I've blown up 2 of the pictures. Again, it should be the same size in order for it to be symmetrical, but it's just a little bit hard for me to do that. So I'll try and make it as symmetrical as I can. So which of these can I turn and it still looks the same? I'm hoping this is pretty obvious to you already, but I'm going to really make it visual. If I turn the flower around, so I just turned it, that would be 90 degrees to there. Yep. If I turn it another 90 degrees, still looks the same. Another 90 degrees, still looks the same. And then all the way back to the beginning, looks the same. Here we have the hat. If I turn it 90 degrees, nope, doesn't look the same. Another 90 degrees, nope, doesn't look the same. Another 90 degrees, nope. And another 90 degrees, back to normal. Then it is. But when I'm turning it, The only one I think you could probably imagine for this image over here of our octopus, just like the hat, it's not going to look the same upside down or any way spun around, rotating. So the only one here with rotational symmetry is our flower in the middle. Okay, I think that's all you need for this. Oh, no, there's one more example I'm going to add actually. In this last example, they say, this image has rotational symmetry. Yeah, I can tell by looking at it. What is the smallest number of degrees you need to rotate the image for it to look the same? So what they mean is, if I turn it just a little bit, that does not match up here because now I have a circle at the top and there's no circle at the top there. So let's take it back to where it was to start. I have 2 circles at the top. Then I have to turn it, so back to 2 circles. So there. So they're asking, how far have I turned that around? So I think this little image over here might help us. If we turned it 90 degrees, that would be all the way around to here, which we didn't do. So I think we went about halfway between where we started and 90. So I would say, I think we went 45 degrees. So that's why I've sort of included that sort of in the picture here. So you might want to look at this. If you have to turn your shape from start to there, that's a 90-degree turn. If you start here and you have to turn it past 90 degrees, a whole way, so it's essentially upside down, that would be a 180-degree turn. And I think that's probably the biggest it's going to be. Okay, that's it for now. Good luck on this section.